Hi my friend, welcome to Joey's Tech, and in this video of Joey's Tech we are going to solve the word break problem using dynamic programming, which is one of the most interesting problems of all time. Without wasting any more time, let's jump to the problem statement. So you are given a long string containing words with no space. And in this video we'll be using the string ILIKE. So as you can see, it contains certain words, but there are no spaces between those words. Okay, it's a string, it's a sequence of individual letters. Now along with this string, you are also given a dictionary in which there are a few words, which are I, like, mobile, eyes, boy. So you are given this dictionary as well along with this string. The problem statement is that you need to find if the given string, which in our case is ILIKEICE, can be divided into segments or substrings when all of those substrings must be present in the dictionary. All right. Okay, this will be very much clear in the next slide. So as you can see, this is our string ILIKEICE. If I put a split after I and another split after LIKE, then I get three words which are I, like, eyes. Okay, and these three words are present in our dictionary. In the dictionary which is given to us, these three words are present, and hence the answer is true for this string. All right, so if one is going to ask you that this is the string ILIKEICE, okay, according to the word break problem, can this be divided into substrings which are present in the dictionary, then your algorithm should calculate it as true. That is the answer. Okay, now there are some recommendations provided by me for quick understanding. So the solution to this word break problem can automatically occur to you if you are going to follow these videos one by one. So one is the intuition to solve a longest palindromic subsequence. So you need to develop the intuition how to solve the longest palindromic subsequence. Second, solve the longest palindromic subsequence. Third, solve the longest palindromic substring. And fourth, the palindrome partitioning problem. Believe me, if you are going to solve all these four problems by yourself or by watching the videos of Joey's Tech, the link to which I am giving in the description, then word break problem will be a piece of cake for you. Really, because you will be establishing the connections among different dynamic programming problems, and those connections are the key to solve any dynamic programming problem given to you. So now let's move to the framework where we are going to develop the algorithm to reach to our solution, which is true in our case. So here we are at the framework. As you can see that I have put the words available in the dictionary given to us over here. All right, and this is our matrix that we are going to fill in order to find out whether our string, which is this, which I have written over here, okay, as part of our columns as well as part of our rows, ILIKE, eyes, can be divided into substrings which are present in dictionary or not. All right, so we are going to start from the smallest subproblem because we are solving this word break problem using dynamic programming. So the smallest subproblem is going to be of length 1. So we are going to focus on individual letters when it comes to length 1. So the first letter is going to be I. All right, now is I present in the dictionary? It is present in the dictionary, as you can see. Okay, in cell E1 I can see I. So what I'm going to write here, I'm going to write here true because it is present in the dictionary, and this is the lowest subproblem. It's the answer to the lowest subproblem. So if we are given a string which contains only one individual letter, which is I, then we can say that yes, it is present in the dictionary. Same we are going to do with the second letter, which is L. Alright, so this particular cell denotes L because as you can see, it is present over here in the column and here in the row. So is L present in the dictionary? No, it is not present in the dictionary, so I'm going to write false over here. Okay, the third letter which we have is again I. So I is present in the dictionary, so I'm going to write true over here. Alright, K is the fourth word which is not present in the dictionary, so I'm going to put false over here. For E, I'm going to put false. For I, again I'm going to put true. For C, I'm going to put false, and for E also I am going to put false. Okay, now the length of our subproblems increases to 2. Now we are going to consider 2 letters. Alright, so we are going to start from here. So our first subproblem will be IL. Alright, so I am going to, for simplicity, I am going to put IL over here. Okay, let me bring it in the middle. Alright, so is IL present in the dictionary? No, there is no such word as IL over here. So I am going to mark it as no. Alright, so there will be one case. If I split I and L, so I am going to put I over here and L over here. This means that I am splitting both I and L. I have split I and L. So now I am going to look at the individual cases. So for I have already calculated whether it can be divided into substrings which are present in the dictionary. So from where I am going to get the value of I? From this cell, because it is the cell of I, as you can see, I and I. Alright, so I am going to get true for this I, and for L, from where am I going to get the value? I am going to get the value from here, because this cell represents the value of L. So true and false become false. So I am going to write false over here. Alright, now the next subproblem becomes Li. Okay, so I will put Li over here. We put that in small case to avoid confusion. Is it present in dictionary? No, it is not. Alright, so I can put a split between L and I. Alright, just to investigate them one by one. So here is I. Okay, so L and I. So I'm going to look at first L. The value of L has already been calculated here and can be derived from this cell. Alright, this represents the value of L. So the cell which I will be referring to is this. Alright, this I. Okay, you need to keep that in mind. So false and true again become false. So I'm going to put false over here. Now my next sub problem becomes IK. Okay, so it is IK, and it is also not present in the dictionary. In our dictionary, I'm going to put a split between I and K, so it becomes I and K. Now I'm going to look at I, so we need to keep that in mind. Which I we are looking at? So we are looking at this I. So the value of this I is true. Okay, now we need to look at the value of K. So for K, this cell contains the value, as you can see from this matrix. This particular cell holds the value of K. So true and false again become false. So similarly, you are going to consider KE, EI, IC and C. Since they are all not present in the dictionary, and the values of these subproblems look to be similar. Therefore, I am going to put false in each of these cells. Okay. All right. Now the length of the subproblems increases to 3. So our first subproblem is going to be ILI. So I'm going to put ILI over here. Okay. Is it present in the dictionary? No, it is not present in the dictionary. So no stays there. I'm going to delete it, and then the first split is going to be put after I. So I am going to put I over here and then Li over here. Now the next case is going to be IL and I. That means I am putting my second split. Okay, this is the way we are going to calculate. And it has all been described well in the palindrome partitioning problem video of dynamic programming, which I made before this video as well. All right, so for this, let's calculate our result. So for this I, we are going to refer to this cell because it holds the value of I. So one value we are going to get as true, and for this Li, which cell we are going to refer? We are going to refer this cell. As you can see, this you can view it like this, L to I. Okay, so this is the cell, or you can check it like this as well, Li. So this is the cell which holds the value of this subproblem Li. So Li is false and I is true, so we are again going to get false. All right, now we are going to refer to the second case. So IL is the value, is the subproblem which we are going to be looking at. So IL is this, from I to L. So we have false as the answer to our subproblem. All right, and then the second part holds I. So we will be looking at this I, because we are looking at this subproblem ILI, and I have put a split after this L. So this I is false and I and L are false. So false and false again make false. So there will be no change in this value, in this cell's value. All right. Okay. So now we move to our next subproblem, LIK. So let's quickly solve LIK. So it is not present in the dictionary. So first is going to be LIK. After L there will be a split, and there will be a split after LI and K. All right. So for the value of L is false, which comes from here, and the value of IK is going to be false again. All right. So this I to this K we have false, and L is also false. So I am going to put false over here. Now the next case is Li. So Li, the value of Li is this particular cell. As you can see, from L to I we have this cell, false, and the next section is K. So K is this value, false. As you can see, K to K. Okay, so false and false are going to be false again. So no change in the value of this subproblem. Okay, so let's move to our third subproblem, which is going to be IKE. Now this is also not present in the dictionary. Let me quickly write the test cases. So I'm going to put the first split after I. So KE will be in the next section, and IK after I put split after the second letter, IK will be in my first section and E will be in my last section. So for I am going to get the value from here. This is true. All right. And for KE, so KE will be K to E. So this is false. So true and false are going to make a false. And let's move to the second test case, which is ik. So as you can see, ik is this value, which is false, and e. So individual e. So this is individual e. So false and false are again going to be false, and that is why there will be no change in this value of ike. Okay, so I am going to put my next subproblem over here, which is going to be kei. So for k, we are getting this value false, and for ei, I am going to get, this is ei. Okay, so false and false are going to make it false. Okay, now for the next test case, we have ke. So ke is this value, and I. So I is this value, which is true. So false and true again make false, so no change in this value. Okay, so I move to EIC now. Now this is also not present in the dictionary. The first test case will be E and IC in the next section, and for the second test case, EI will be in the first section and C in the next section. Okay, so here is the cell where we will be putting the result of EIC. So as you can see, individual E contains false, okay, because it is not present in the dictionary, and IC. So what is IC? This is the value of IC. So false and false are going to make false. Now we have EI. So EI is this value, and we have C. C is this value. So false and false are going to make false. So no change in this value. Now we move to our last subproblem of length 3, which is ice. Okay, so let me put it over here. Let me eliminate it and let me put ice over here. Now, is this ice present in the dictionary? Yes, it is present in the dictionary. It is our fourth word. So I am not going to do any dissection of ice because it is present in the dictionary already. I am going to simply write true over here. That's it. Okay, and this is the answer to this subproblem ice. Now the length of our subproblems increases to 4. So the first subproblem which is going to come into picture will be ILIK. All right, let me write it over here. ILIK. So is it present in dictionary? No, it is not present in the dictionary. Let me write no over here. Now what will be the cases? Okay, if I'm going to put splits after each letter, okay, one by one, then what will be the cases I'm going to get? So if I put split after I, then I'm going to get LIK, I and LIK in the next section. Then if I put split after the second letter, then I'm going to get IL and IK in the next section. And if I put split after third letter, then I'm going to get ILI and K in the last section. Okay, so let's solve them one by one. So for I have true already here. And what is the value of LIK now? So LIK is this problem. So it starts from L, it ends at K, and this cell holds the value. So true and false is going to give me false. So let me write it over here this time, okay, to bring a change. All right. Now IL. So IL is going to be this value from I to L. So this false along with IK. Now which is IK? So IK is this. So it starts from this I and it ends at this K. So this is the cell which we are going to consider. Okay, so false and false again going to give me false. Cool. Now the third case has the first string as ILI. So ILI is this cell because it starts from I and it ends at I, and we so for our third case, the first string is ILI. So ILI is this over here. So it starts from I, it ends at I, and this cell holds the value. So it is going to be false. And the last string means the string in this section is K. So let me check what is the value for K. This is the value for K from K to this K. So false and false become false again. Alright, so I'm getting all falses. So I'm going to put false over here. Alright, so the next subproblem of length 4 becomes LIKE. So let me put it over here, LIKE. So is like present in the dictionary? Yes, it is present over here. So I'm going to put yes. And when we do that, then what I am going to type here, I am going to put simply T over here. So the next problem becomes IKEI. All right. So let me put it over here, IKEI, and it is not present in the dictionary. So I'm going to write no over here. Let me quickly write the subcases, IKI, then IK, and EI, and then IKE, and then I. All right. So for I am going to get true from here. I'm sorry, from here. Okay. So for I am going to get the value from here, T. And then we have KEI. So this is KEI, and from it starts from K, ends at I. So this is going to be my cell. So false and true, they become false. Okay, now IK is the next string. So IK is this string, as you can see, it starts from I, ends at K, so false. And EI, so EI is nothing but this cell, so false and false become false. Similarly, IKE, which is this cell, and I, which is this cell, true, they also become false. So we are not getting true from here, and hence we are going to put false over here. Okay, so now our next problem becomes KIC, and it is also not present in the dictionary. So I am going to dissect it. Let me quickly write the cases. Now, if you are going to follow the same method, then you will get false for each of these test cases, and hence in order to save time I am leaving this exercise to you, but here I am going to put false to move this solution ahead. All right, now last subproblem of length 4 is going to be EICE, which is also not present in the dictionary. Quickly writing the test cases. All right, so we are going to get false for this again, then false for this again, and false for this again. All right, please do that yourself, okay, because it will make the picture clear for you. Okay, because this is what our problem is. Now if you have this doubt in your mind why I am putting the splits, then just reiterate the problem statement in your mind that this is what we have to do, and that is why I am doing this to every subproblem. Now I am going to put false over here. Okay, the length of my subproblems increases to 5 now. My first subproblem becomes I like. All right. So I like. Is this present in dictionary? So it doesn't present in dictionary. So it's going to be no. But I'm going to write the test cases for it. Now let's consider the first one. Okay. Over here. So let's first focus on I. The value of I is going to be true, and the value of like, let's find out the value of like. So the value of like from L to E is again true. So I have got two trues, and that make the value of this cell as true. So now I have got true. So even if I get false for all these test cases, I am going to put true over here. Okay, let me put true over here. And with this 2, I am going to put one number, which is 0. Why I have put 0? Obviously, this question is going to come to you. I have put number 0 because I have put split after the letter at index 0, as you can see. This is one of the ways to find out where I have put the split. Okay, now let's quickly look at these test cases as well. So IL is going to be false, and IKE is again false. So we are going to get false, which is not better than true. So I'm going to put true over there, means true stays there. And then we have ILI. So ILI is this value over here. ILI is this value from I to I, false. And KE, so KE is this value. So true and false again become false. Similarly, we will have false for this case again, and which is not better than true, so true stays. Okay, now let's jump to our second subproblem of length 5. So this is going to be ILIKE, I'm sorry, LIKEI. Okay, and this will be the cell where I'll be putting it. Fine, so this is not present in the dictionary. Let me quickly write the test cases. These are few subproblems which I have already solved, and I leave it to you to solve these and get to their results. But let me tell you in advance that their results are going to be false, but I am going to focus my energy on this particular test case. So let's look at the value of like. Now as you can see that the value of like is true, all right, and this I. So this I over here, the value of which is also true. So true and true become true. So I put true over here. All right. So this makes the value, the answer to this subproblem as true. 4 over here. Question is why I have put 4, because as you can see that I am splitting after K, and K is at position 4. So 0, 1, 2, 3. I'm sorry. It is after position 3. So I will put 3 over here. All right. Because I am splitting after K, and K is at index 3. This is 0, 1, 2, 3. Hence I put 3 over here. Alright, this is going to help us identify the splits, okay, after we have completed the matrix. Now the next subproblem becomes IKEIC. All right, okay, IKEIC. It is not present in dictionary. So let me quickly write the cases. Okay, if you are going to find a solution to all of these cases, and in the end to this problem, everything is going to come out as false. So please do that in practice. I will put false straight away here. All right. Now the next subproblem becomes KEICE. Okay, so it is KEICE. Like the previous subproblem, it is also not present in dictionary, and the test cases will become the values of all of these cases, okay, are going to be false, and thus let me put false directly over here. Now the length of my subproblems increases to 6. Okay, so my first subproblem becomes ILIKEIC. Okay, let me quickly write that down. ILILIKEI. Okay, and this is also not present in dictionary, so I'm going to put the splits I and ILIKEI. Right, so these are my cases. Let's examine this first case. So it is going to be, for I, the value is going to be true. Okay, and let's examine the value for LIKEI. So LIKEI is this subproblem. So it starts from L and it ends at I. All right, so it is going to give me true, because I'm going to get true over here. Okay, and I will put number 0 over here. I got it from putting a split after letter at index 0. Now for the rest of all these cases, you are going to get false as the answer, so true is going to stay. Let's examine our second last subproblem of length 6, LIKEIC. So L, the cases are going to be, so these are going to be the cases. Okay, I leave it to you to find out the values of all these cases, and finally the value of the subproblem. But I know in advance that it is going to be false, as it is evident already. So by this time you would have also got the idea that we are looking at a subproblem for which the result is going to be false. So let me quickly fill that out over here. Okay, now the last subproblem of length 6 becomes IKEICE. So these are the test cases, okay, of our final subproblem of length 6, and these all are going to be false as well. So I put false over here. Okay. Now the length of the subproblem increases to 7. Okay, so our first subproblem becomes ILIKEIC. Let me put that over here, ILIKEIC, and it is also not present in the dictionary, so the answer is going to be no. These are all the cases when the length of the subproblem is 7, and it is ILIKEIC. The answer is going to be false for all of them, and hence we are going to get the answer as false for this subproblem as well. Okay, Now the next subproblem becomes like eyes. Okay, so by this time you know how to make the test cases of a particular subproblem. Okay, for this subproblem I am going to be looking on one single test case, which is going to be LIKE because this is going to give me true. All right, so for like, which cell will I be looking at? Let's go and find it out. So for like, from L to E, so this is true. All right, and for eyes, which cell will I be looking at? This one, from I to E. All right, so true and true become true, so I'm going to get true over here, and with this I will be putting the number as 4, because as you can see I'm getting it after putting a split next to the letter I, and I is indexed at 4th place. Okay, 0, 1, 2, 3, 4. So I am putting 4 over here. All right, now the length of the subproblem increases to 8, which is also the length of our string. So let's examine this. Okay, so I like eyes is not present in dictionary, so it is going to be no. The first test case is going to be I like eyes. All right, let's examine this case first. If it gives us true, then our problem is solved. So let's go and find out what the value of I is. It is true. Okay, we have found it out several times in this problem, so it is true. And let's go and find out the value of like eyes. So like eyes is the one which starts from L and ends at E, so it is also true. So true and true give us true. You can also examine, you are welcome to examine the next few cases by putting the splits after each character in this subproblem. But even if you get false, you have got your first true, and I'm going to be putting true over here. So let's put true over here, and I will be putting 0 as the number because I have got it after putting the split next to the letter I, which is at index 0. So we have got the answer to our solution, that yes, I like eyes. If I am going to strategize the splits, if I'm going to put the splits at right places, then I will get segments which will be present in the dictionary given to me. Okay, so true is the answer. Now if someone asks you to find out where you are going to put the splits, okay, let's find that out here. So we have on this last cell we have the number as 0, so that means I is out. All right, so I'm going to put I over here. Okay, this means that I have got my first split after I. So I'm going to put I over here. All right, and then I am remained with like eyes. Like eyes. So it starts from L, it ends at E. So I will be looking at this value, and I get the number as 4. So what I get till index 4. So this is 0, which is already there. Then we have 1, 2, 3, 4. So I will be putting like over here. Okay, and after that, okay, I am remained with eyes. All right, so let's find out what we have at eyes. So I am getting true, and there is no number here. That means that I am going to consider it till the end. So ICE I'm going to put over here, and this gives me the right answer. All right, now let's quickly see the algorithm. So this is the algorithm. If I to j is in the dictionary, then tij is directly going to be true. Else there has to be existing k, which the value of which is going to range from I to j minus 1. So if tik and tk plus 1 j are true, then only we are going to insert true in tij, else we are going to insert false. So with this we have come to the end of this video. It was a long video because it was a big problem. Okay, there were too many letters in the problem. I hope you enjoyed it. If you enjoyed it, do give it a thumbs up. I look forward to help you with programming and algorithms. Thank you and goodbye.